coming straight back to the very beginning. I'm from Oracle, but I'm not selling you anything at all, just common sense. The title is, loosely speaking, how best to do a PL/SQL performance experiment, and I'm going to interpret that goal statement for you in a moment. Who am I? My name is Bryn, easy to remember and pronounce. The last name is Welsh. It's conventionally pronounced Llewellyn in England. And I'm a product manager, which means that I am charged with understanding every corner of PL/SQL from the point of view of people such as yourself, and for that matter, every corner of something else called edition-based redefinition, which I won't mention today, but which I'm talking about for a whole day tomorrow. Enough of that then. I live in San Francisco, but I come from the United Kingdom, and I work at Oracle headquarters. Moving on then. Yes, that was the title, 10 rules, because studies have shown that if an audience sees, 10 rules, they're going to come, because they think it's something they can learn. But really, I'm speaking more abstractly. And the first thing I have to say is, what do I mean by a PL/SQL performance experiment? And to get the context for that, who came to the talk I did yesterday? A lot of you. Okay, that's enough. I'm not going to go over all the ground again. Let me just say that for those of you who missed it, the bigger picture is obtained by a little bit of Googling. If you remember only my name and PL/SQL, which you're bound to remember, then that in Google takes you to such obvious hits as this, including, for example, why use PL/SQL? And that is a paper, carefully written paper and reviewed by my most respected colleagues, which gives the argument that I gave yesterday. And there are other things. In particular, there's this. Everything I said that set the stage for yesterday and a bigger picture of all that stuff, why we are so keen on getting people to remember again the old wisdom and have all the so-called business logic, everything like that in the database behind the PL/SQL API. All the thinking there is in a quite easy-to-watch movie, broken up into episodes. And the other thing, there it is, just to make sure you know it's real. And I don't know if you recognize that face. That's the famous Toon Koppelaars from Holland, the Netherlands, who also works in the real-world performance group and has no end of war stories about how things go well or go bad, according to the philosophy that I explained yesterday. With me so far? So do a bit of study there, please. Last point, because there was such a good talk on architecture notions yesterday, I would just like you to remind you that a decision, A, to have the database as a bag of tables and everything to do with logic outside of it, as the group I was in the architecture workshop on Monday argued for, or B, to use this hard shell approach, that is most certainly an architecture choice. It's a kind of architecture choice that you can understand the pros and cons for pretty much independently of any specifics of the application, given only that some bigger picture analysis has shown that you're going to use an Oracle database somewhere in the picture. Moving on, who came to Martin Widlake's talk yesterday about instrumenting things? Only some of you. He was, his high-level point was, if things are said to be going slow, where they are said to once go fast, you can't survive on anecdotes like that. You need instrumentation. That was his basic point. But he didn't make the main point that I would make, and he couldn't make it without a bigger context, which he perhaps didn't want to establish because he knows that many people are not in that context. But just think of this. If you adopt the hard shell approach so that the only possible calls into the database invoke PL/SQL subprograms are not just random ones, but the exact set that exists by design to be the API that expresses each of the business functions that the application as a whole wants to have a database for. If you think of that, and if you think of performance, then clearly the first thing you want to measure is the time for each top-level call, right? Each invocation of a subprogram. Now that can do a million things inside it, SQL statements, who knows what, But that's really what I'm talking about in the context of that architecture. Does that make sense too, so far? Of course, if you find among your business functions that some are quick compared to any user expectation, and some are slow compared to that, you're not going to waste your time making the quick ones go faster. You're going to focus your attention on the slow ones. And one last general thing, in that regime where you've discovered a particular top-level call is slower than you'd want, you want to speed it up. How do you speed it up? Not by reading the source code and looking for a better way to sort something microscopically. You find where the time is going. Who has heard of the hierarchical performance profiler in PL SQL, sometimes called HPROF? A disappointingly small fraction. It's been around forever. Basically what it does is tell you the total time of the subprogram you've got in your hands for observation. And it breaks that down into self-time, you know, the ifs and elses and so on in itself, and subtree time, all the time spent in the guys it calls. And your expectation is that the top guy has an infinitesimally small self-time because he's just the big monitor. Do this, do the other, do the other. And so it goes on. And you drill down using this tool till you find the subroutine among the lot that's taking a noticeable amount of time that's interestingly big in the big picture. Guess what? When you implement the hard shell, you've got a choice of 2 different languages for your subroutines. One is PL SQL and the other is SQL. And the other part of the hard shell philosophy is to aim to do all the heavy lifting by spelling the reasoning in SQL, not PL SQL. So typically in a well-ordered hard shell implementation, you use this hierarchical profiler thing to drill down quickly to the SQL statements that are problematically slow. So that's the context for everything I'll say today, but I'm going to choose a trivial example. Moving on. The one I'm going to choose. It's a scheme. I could have picked many things, but it's easy to do an experiment with, and it brings out lots of points. Who has even heard of Pragma UDF? 2 or 3, okay. Who has heard the claim, a claim which turns out to be depressingly true, that if you have a SQL statement with a relatively complicated expression in it, all of which is in SQL expressions, and if you think, oh, I'd like to use that expression in 2 places, I'll make it into a function, and the only language you have for writing a function is PL SQL. Then, if you do that, the SQL statement, when it scans many rows, slows down. Who's heard about that? Yes. Any idea what the typical factor is for a very lightweight subprogram? If the subprogram is doing a lot of work, it couldn't have been in a SQL expression in the first place. It's a sort of artificial thing. I'll tell you, you can get 5x, factor of 5 slowdown, just by encapsulating. This Pragma UDF and everything that goes with it was an attempt, new in 12.1, to find a way to compile PL SQL in a better way to make it go faster under those circumstances. That's the background. There's more to it. I'll try and fill out the detail. The basic idea is we found a way to do the compilation of PL SQL to make it go faster when a PL SQL function is called from a SQL statement. Unlike our friend Kamil, who spoke yesterday, you don't need to know anything about how we did it. You just need to wonder how big its effect is and then want to measure it. Okay? Now, it turned out that we couldn't do this performance improvement just like that. We had to do a trade-off. Doing this new way of compilation made it a lot quicker in SQL, but marginally slower when the guy was called from PL SQL. So we were forced to leave it as a knob. The knob is Pragma UDF. If you put Pragma UDF in a function, you have it optimized favorably for use in a SQL statement. If you don't put it, it's slightly less, well, it's normal rather than a smidgen disfavorable in PL SQL. That's a simple way to think about it. Have you heard of the possibility of putting a PL SQL function definition in a with clause? Who's heard of that? A few more, okay. If you do it, I'm sure you can guess that the PL SQL function can't be used anywhere except in that SQL statement, because it's invisible in schema scope. That means we can secretly compile it in that special way. So that's another way of getting the performance benefit. The feature, put a PL SQL function in a with clause, wasn't designed for that purpose. It wasn't designed to be a performance thing, but if you use it, it inevitably gives that performance benefit. It was done just for code clarity, modular notions. Okay then, we're more or less there then. The scene is set. We now can see that for an experiment that's aiming to discover, does this new feature deliver anything of value, you need to compare the time of a SQL statement, let's make it a select statement, who runs through a big table with a certain expression in it. Then, as a baseline, you'll redo that by putting that expression in the body of an ordinary PL SQL function as it used to be at 11.2. You got that? Two possibilities. Then you redo the timing, obviously you're timing all these, you redo the timing where the function is marked with this new magic knob, pragma UDF. Then you do it again where the same logic is in a with clause. 4 different ways of doing the same basic functionality. Okay? Got that? And then someone pointed out there's a 5th way. You leave the thing at schema level. You don't touch it. You don't make any changes. You don't turn the knob. But you write a tiny jacket in a with clause function is simply a pass-through to invoke that guy. Does that make sense? See what I mean by a pass-through? A jacket? So that's 5 ways. So now we've got kind of the basis for an experiment. Except what we found, I should say that this new stuff in 12.1 was a big invitation to the whole world of bloggers to time it and write about it and do blog posts about it. Everyone who did it picked a tiny subset of the space. They compared this with this data type in and that data type out. And they said, oh, this is really good. 5x, wonderful. Someone else, different thing, a different varchar 2 in, varchar 2. This is bloody rubbish. No effect. And nobody thought of what are the degrees of freedom and how do we do a systematic experiment. That is my point. You with me so far? Right, good. So now we'll move on. Here come the rules. Let me make sure that I can see how we're doing. 10 minutes into it so far. It's impossible to stand there. So rule 1, I have to stand back a bit from the searchlight. You're going to do an experiment. It's going to have some pieces in it. You're going to have the programs that you're interested in. You're going to have probably some tables that you'll be doing stuff with. That's a kit of objects that you need to install. The last thing you do is just type stuff. You're going to need an installation kit. Write that kit so that it installs everything. Write it carefully so that it always runs silently unless something goes wrong. Nobody bothers to do that, but it's good advice. Just twiddle the degrees of freedom in SQL Plus so that it doesn't keep on saying, I did this, or I did that was successful, because that's just noise. You want it to be pretty much silent, because then you can see, oh, nothing to see. If it goes wrong, then there'll be more text, and you'll work out what goes wrong. This is while you're developing it. With me there? And you want to write it so that it'll run silently that way in a freshly created database. You want to write it so it'll run in exactly the same silent way immediately after you had installed it. And you want it to work that way if you pulled the plug on it when it was halfway through something. And it's easy to do that too by encapsulating all your create statements, which you know might fail if the guy exists, and therefore you have to drop the guy, but the guy might not be there to drop, and that's an error. You can do that in the PL SQL you know. Okay? With me? Begin, actually not begin, declare, you know, E, exception, pragma exception init, E, map it to the number that corresponds to, I tried to drop a table and it wasn't there. Begin, execute immediate, quote, drop the table in question, quote, right? Exception, when the table wasn't there, don't care, right? And then you're always silent, you always succeed. That's the aim. Still with me? Good. Try to be a little bit more vocal if I say, still with me, yes? Good, right. In short, right, I said that. Now, you're going to have data. there's practically no use for PL SQL except for manipulating data in tables in some way or other. So any test that's interesting in the real world is going to involve SQL, therefore you have to have tables. Which tables? The tables that are most suitable for this experiment. What's the chances that such a set of tables will pre-exist? 0. So you have to build the tables too. What are you going to call them? Please do me a favor. Don't start talking about your children and the books you've written and the pets you have and the beer you like to drink. That's just distraction. Just have table T, column C, that kind of thing. If you need 2 tables, master detail, table M for master, table D for detail, because then you're expressing the idea that you're approaching this in a general fashion and your typing is small. Did you go to that talk yesterday about naming things? Yes? This is a special case of naming things where the names have no specific meaning in the real world. Rather, they are meant to represent the idea of a table, the idea of a master table, the idea of a details table. So M, D, and so on are good. Okay then, that's that. Rule 2. The temptation is when you need some PL SQL and you're being ad hoc, just to type up begin, blah-de-blah-de-blah-de, end, right? I'm saying never do that. Just take that tiny little bit more effort and record that code in a procedure or function, whichever is appropriate. If it was going to be an anonymous block, then it can be a function, a procedure with no formals. Why? Because PL SQL has warnings. Who regularly uses PL SQL warnings? A handful of you. Just remember the purpose of this conference. It's to bring together people from different programming disciplines. I bet if you went into a Java or that kind of track and said, who uses warnings? Everyone would put their hand up. They'd think you'd be mad not to, okay? Warnings tell you about various things you're doing that are nominally legal, but that can be bad in various different ways. And which do you think it's better? To ignore all that, not even to know, or to have a chance to consider all those things an improvement? Obviously B. So you want your warnings on all the time in development. The thing is that an anonymous block, because it's just so much on the fly, can't give you warnings, but the procedure encapsulation of it can. So that's why that is. Okay, turn on warnings. And if you didn't know, that's how you do it. Okay, I'm not interested in the knob you have in SQL Developer, sorry, Stephen Feuerstein, to do that because you're writing a script that you can run and run and run again, and you want the script always to work. When you post it to your friend in a different country, you just want it to be self-contained. You don't want to write a big essay. In SQL Developer, remember to go over there, click this, pull that down. With me? Yes, good. Okay then, rule 3. Make sure, this is critical now, it's self-evident, isn't it? You're never going to be interested in the time for just one thing. You're obviously going to compare things. If it was Martin, he's comparing the time of something yesterday before I upgraded the Oracle database and after, because my plans might change. Here, we want to compare the time with this new mechanism and without it. In fact, without it and with it in that flavor, and that flavor. Yes? Any experiment is going to be a comparison, not an absolute number. That means one of the tests is going to be the natural baseline. In Martin's thing, the baseline is what it was before I upgraded. The new thing that you want to compare to the baseline is what it's become. Has it got faster? Has it got slower? How do you express that answer? Not just by saying, well, before it ran in 17.326584329 seconds, and now it runs in 18.8642. Therefore, you can read those numbers, all 73 digits of it, and work it out for yourself. No, you present the answer as a ratio. Baseline, it was 1. The new time is 1.05. Even that is not useful because you need to repeat the experiment. And if you're getting, the comparison coming out as 1.05, 1.0, 0.9, well, there. you've learned something too. You need a statistical effort, don't you? So the other thing is, of course, I've said all that lot, the next step in the thinking. In most of these, not the Martin scenario, but in our kind of scenario, you will find when you write the programs who you want to compare the times of, they have a huge amount of text in common, okay? A different experiment might test the assertion that a value, a lot of numbers, let's say, a collection, is quicker when you operate on it if it's declared as a nested table than if it's declared as a integer by PLS, index by PLS integer table, okay? Maybe someone told you that in a parking lot. Is it true or not? Better do the test. The way you do the test is by noticing that almost all the code in those two versions is identical. You can differentiate them for the reader to see by using conditional compilation. Who uses conditional compilation? 2 or 3. I bet if you asked that same question in a Java stream, you'd get an entirely different answer. That kind of is a message to you. Try to get a little more forward-looking so that when these Java people tell you that PL SQL is rubbish, which they love to do, you will have some comeback. But if your focus of how PL SQL works is ignorant about all the things we've done in the last 5, 10, 15 years, they might demolish you with their arguments instantly. Right then, I won't give the details of how conditional compilation works. Basically, it works like it does in any programming language, and you can look it up. But the beauty of it is, it lets you just write this at one spot in your program, turn a knob one way, compile it, it works like that, turn it the other way, it compiles, it works like that. So you're surest that you are measuring the right thing. Still with me? Yes, good. Do you remember what the naming, who went to the naming things talk yesterday? Just one, oh dear. Well, never mind then, but he showed this big picture, which was a pie chart. Studies have shown that the time it takes to write a program is a tiny fraction of the time that people spend reading it, including yourself. You know, it's like not like 60-40. It's like 5% you write it and 95% you and other people read it. This is a device to make reading it easier. He stressed that point. Always adopt approaches that make your source code maximally easy to understand. Never mind if you have to type a bit more to reach that. Okay then, rule 5. This is more common sense. It's kind of generic notion of testing, isn't it? You risk, if you just start from a random position, that you'll be the victim of inessential things. You want to somehow set a baseline with respect to things like caching and similar, things like compilation and similar, compiling your your SQL statements, that kind of thing, hard parse, all that lot. After all, the whole of Oracle is designed in the expectation that at runtime, there'll be no compilation going on and lots of things will be cached. So you want to be in that environment when you do these experiments. Do you see what I mean? So that means, in a theoretically ideal case, you would reboot the computer, start up Oracle again, then run your experiment in this scripted fashion once, and then start to time things. Often you can reason that you don't need to reboot the whole computer. You can reason that you don't need to restart the instance. You can reason that you don't need to flush the shared pool. But you have to think about that kind of thing. Okay? Ideally, to put it this way, you couldn't go wrong if you did that, as long as you did the warm-up as well, right? It would be just a bit more effort than perhaps you'd feel like doing. Okay, then, rule 6. Design the test so that it takes an appreciable time to run. I don't know how many people try to convince me that method A is quicker than method B, when the time it takes to do method A is 0.1 seconds. You know, madness. I don't understand how they think like that, but they do. So please don't. You want to choose a time that's big. What does big mean? It's a noticeable number of clock ticks. What's a clock tick? It depends what clock you use. right? But you want, all these clocks have a granularity, don't they? And you want to have something like 1,000 clock ticks for the duration of your experiment to have numbers that you can trust. Because if you repeat it, first time 987, it's not going to be 987 next time, is it? If the granularity is 1 unit and the first time it's 3, the only things it can be next time is 2, 3, and 4. And 2 is very different from 3. 4 is different from 3. So that's crazy. Still with me? So what clock are we going to use? Certainly not SQL Plus's set timing on, for many reasons. One, it's methodologically wrong because it times the time from when you say go in SQL Plus across the network, in through the layers, into the database, blah, 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 back out through the layers, back across the network, and back to SQL Plus. Now, never mind if you think, oh, in this test it doesn't matter. That's just, immoral thinking, isn't it? It's thinking for which people... And there's such a simple way to do it right. You want the clock in the database. Now, what clocks have you got in the database? You've got sysdate, you've got systimestamp, and so on. They all measure only wall clock time. You've also got DBMS utility get time and DBMS utility get CPU time. And those are the only matched pair, that give you wall clock and CPU. What do you think? In an experiment like this, is wall clock time necessarily the best measure when it's all about computation? What do you think? Which do you prefer, wall clock or CPU? Who prefers wall clock? Second one, CPU. Yes, there's only one way to get that, DBMS utility CPU. It's called get CPU time. It reads the time, you read it again, you take the difference. What are the units? Its ticks are centiseconds. So you're stuck with that. So your test should run 1,000 centiseconds, roughly. How long is that? 10 seconds, right? That's not going to be a problem. If you've got 50 things to compare, the whole experiment will take 50 seconds. If you want it better, you can double it. It'll take 2 hours. You can, after you've set it up so it's fully mechanical, let it run overnight, can't you? It doesn't matter how long the experiment takes. Moving on. That was all that first bit of it. Now, when the time comes out, what are you going to do? A, just print it to the screen with DBMS output and copy and paste that into an Excel spreadsheet, or even worse, an email that you then send to me immediately without thinking. Or are you going to B, write it into a table in the database so that you can later do some statistical analysis? It's B, isn't it? Anybody think it's not B? Anyone think it's A? Good. That's a better way to ask a question, isn't it? If I ask all my questions in the negative and you never say anything, then I'll feel you've got every single point I make. Right, so we're going to have a procedure, record time. What's it going to record? Obviously, the number of centiseconds with no interpretation that each run of the experiment took. That and only that? No, of course not. There are going to be other fields in the row. There are going to be other columns in the table. Which columns? I don't know. The columns that are appropriate to the test at hand. So you'll design the table for recording your results on the fly as you're doing the experiment, unfiltered, with your experiment in mind. What are the degrees of freedom here? We noticed that there are 5 ways of doing it. Pure SQL expressions are kind of super baseline. The old 11.2 style in PL SQL as the baseline of interest, as we'll see later. With this new magic UDF knob, straight in a with clause function, or number 5, with the thing as it used to be in a jacket in a with clause. Okay, 5 ways of basically doing it. Is that the only degree of freedom? I hinted already. Do you remember what I said? What's the other degree of freedom? One guy measures it, me, for a talk. I choose number. Brilliant. 5x improvement, wonderful. Widlake, who wants to get on my nerves, chooses varchar 2. No difference. Now I've said it. What's the other degree of freedom? Data type. What's data type in a function? There's data type in, there's data type out. Oh dear. So we've got to consider number in, varchar 2 out, varchar 2 in, number out, all the combinations. How many are there? number, date, varchar 2, do the combination thing. That's a lot, but there's more. There's binary float and binary double. For the purpose of having a talk, I scoped it. I did all the combinations of the first 3 scalar data types. That's 9. And then I did the other 2 by themselves. Float in, float out, double in, double out, just to get a sense, okay? And user-defined types, for this, I couldn't bear that. I held that out of scope. Okay, then. So this procedure, record time, is going to put the time in a table, presumably one with a synthetic surrogate key on it of a identity thing, because this is all new 12.2 in my case, and annotate it with the other salient facts about the experiment. Okay, moving on, rule 8. How's the time going? Not too bad. I said that already, and I said that, and I said that. That's rather good. Rule 9. I squished 7 and 8 together because I was too in a hurry to look at what my slides said. Now then, not only will you just sort of do each test, in this experiment as I described it, 11 of them, just do the 11, you want to repeat each one of them, right? I said that each test is going to run for about 1,000 centiseconds. That's 10 seconds. You've got 5 of them here now. Times 11, that's 55 of them, so the time is going up. And now for each of them, you've got to repeat it some number of times so that when you take an average, you can also calculate the standard deviation so that you can have an understanding of how confident you are in what you measured, yes? You can see already now that the real experiment is probably going to run overnight. Does that matter? Probably not, because you set it all up with very short times so that you can make sure it's all flowing through and everything makes sense, and then just let it rip overnight. Now I'm sort of mixing things a little bit because in Martin's case, where he's got a real production database or a best simulation of it in the development shop at 2 different versions, maybe the basic thing itself takes so long that you can't make it shorter and then it would run for a week and you have to be a bit pragmatic. I don't know. So then, Rule 10, finally, what are you going to show the world? A, just the raw numbers out of the table, and then tell the reader, cast your eyeball over this, do some averaging in your head and have a sense of the variation and draw your own conclusions. I think not. You're going to aim to design the prettiest, least noisy, most elegant, most easy to read report, right? How are you going to get a report out of a table? Oh, well, I think you're going to do some SQL. And if you want to twiddle things around, do you have to obsess to make sure you express it all in SQL using, match, recognize, and analytic functions? I don't think so. You can generate a report out of a table with a few hundred rows in it using any method you please, and it'll have finished before you've got your finger off the button that started it. So your aim is just to focus on designing the most humanly consumable summary of everything that matters, yes? In our experiment, it's going to be a matrix, isn't it? Because it's going to be, on one axis, the 5 different ways of doing it, and on the other axis, the data type in, data type out combinations. Yes? Still with me? 5 across, 11 down. There's one final thing, and I will mention it, but I won't dwell on it in the experiment. I'm going to assume that you know that it's possible to define a PL/SQL function with input parameters where you declare a default value for the input such that if you don't mention anything when you invoke it, you get the default, right? So I'm just going to say, who doesn't know that? Excellent, you all know that, good. Now, I don't know if you all know how it happens, because that might be a surprise. You might think that when you call such a thing, not providing all the values, but letting the defaults kick in, that the guy you call supplies the defaults. No, it's actually the caller who supplies the defaults. Never mind why, that's the case. Now you can see if you had such a function and you invoked it in SQL and you wanted to take advantage of the default values, it would be the SQL side of it who's computing the things and passing them in. Long story short, it boils down to the fact that this whole compilation of that SQL statement has to throw in an anonymous block that you otherwise wouldn't have had, and that adds its own performance penalty. And in a full experiment, that's yet another degree of freedom. So it's not just 5 by 9, it's 5 by 9 by 2, okay? But I'm not going to inflict the other one on you. I'm just going to tell you it's desperately slower when you rely on default values. So just don't do that. If you didn't know that already, now you do. If you want to involve PL/SQL functions in SQL, never take advantage of the default values unless you don't care about speed. Okay then, the other thing, I guess, is that when you finally present this report, which clearly will involve averages, then if you've got a number like 42, to pick a one at random, and if you notice that the standard deviation is 0.6, then you're probably going to quote it as 42 plus or minus 0.6, or maybe 42.5 plus or minus 0.6, yes? If, on the other hand, you find the standard deviation is 0.0002, that's unlikely, but if you find that, then you can fill in the other digits, right? You want to present your final answers with a precision that is compatible with the variances that you've measured in the experiment. That's not a principle that's specific to PL/SQL, is it? That's a general feature of any experiment that involves measuring things and averaging them and computing measures of central tendency and measures of confidence, right? With me? Okay, good. Even the most famous people in the world, Jonathan Lewis and Carrie Millsap in our space, when they show the time of a test, they show it with about 18 digits of precision. And no mention whatsoever about the confidence. So they should have been here today too, but they couldn't come. Right, so now then, and the time that remains, I'll see what I can do to put some flesh on this. But I've said everything that matters, right? Just in case there's not enough time to do the demonstration part of it effectively, we did all that lot, we'll come back to it, never mind the detail of it, and we'll get back to this and this, okay? This is the way the results would look, and just to fit it on the screen, I broke my own rule. I've got a sense of what the confidence is, and I'm presenting the numbers consistent with that, but I'm not showing you the standard deviation. It would be too much to read on a PowerPoint. Now, this isn't really what you want to know, but what I've done down the left is show the actual number of centiseconds that our pure SQL baseline took, just to make sure that I was getting 1,000. Well, of course, I didn't get 1,000, so you could say, I didn't do this experiment right. I really need to redo it, let it run longer. But for a talk, it's okay, you understand the point. And that's just to let you all notice that depending on this magic matrix, of data type in and data type out, then the slowdown factor you get might be only something like 4. It might be roughly 10x or 15x slow down, okay? That's something to think about. But that's not the main focus of our experiment. We knew all the time that something you could have done in SQL is much slower if you encapsulate the expression in PL/SQL. The main thing is that what you need to do is only possible in PL/SQL, and you think, oh, must I? Oh, everything's going to go slow, and we're aiming to speed it up. So really, what's interesting is this box here, where this is the baseline. When you look at these numbers, it's hard to see just how much improvement this magic Pragma UDF made, because you've got to divide 2.6 by 13.6 in your head. So if the numbers are in a table, what is easier than that? Okay, this is the real interesting thing. The baseline time of 1 is the old 11.2 way of doing it. And then these now, rather than fractions, these numbers say how much faster sorry, I'll put it another way. They're percents saying, I have to be very careful how I say this in case I confuse myself. When we see the number in, number out, then the old style of doing it was 1. What's that buzzing noise? And the new style of doing it was 19 times faster. Okay, that's the kind of thing it is. Here we see, oh dear, the ratio of the old to the new was 100%. No difference. Okay then, so it's not the aim of this to interpret the results, and I know that I sort of cut my sentence off because I could see that, my power's come out, we could see that there's a lot to talk about in that space, and it's not the aim of this talk today to explain the details of that. The reason I picked that was only to show you about the degrees of freedom and the way you have to think to do a full experiment. So I'm not going to go into that. Rather, I'm going to do the most I can do in the time that's left, which is roughly 5 minutes or so, over here. So I'm just going to run a script which does the whole thing, the whole soup to nuts. You can see it ran a moment ago. Now I'm going to do it again. What am I going to call it? I've called it 0 because 0 is the fewest keystrokes to type after the symbol at, and therefore there's least emotional barrier to repeating it and repeating it and repeating it. And you can imagine that as I was developing this experiment, I ran it, I don't know, 500 times in succession as I tweaked this, tweaked the other, and so on and so on. But one thing to point out is that there were 3 parts of it. One was just building the whole thing. Then there was running the experiment up to the point that the results are in the table, and then there was generating the report. And once I had stuff in the table, I could work on getting the report prettier and prettier and prettier without rerunning the experiment. Okay, so those were the kind of phases in it. Now here, I adjusted what knob I had on the time to let it run about 3 seconds. That's much too short to have statistically significant answers at the end. What is my knob in this? If I didn't say it before, the basic invocation harness is a select statement. I'm selecting some quantity from a table with lots of rows in it. Okay? And each time I do it, it's a new thing. So the number of rows is the number of repetitions of the basic test. Okay? And just by controlling the number of rows, I can control the duration. So I picked a number of rows in the table that will let it run about 3 minutes. Okay? And by the way, the other thing to say is, anything that is supposed to measure performance and compare different ways must prove that the 2 or many ways are semantically identical. If you leave that out, you could be measuring any bollocks, couldn't you? No wonder it's faster. It's not doing anything. But you didn't notice that because you didn't actually consider correctness. So you must somehow or other compute something like a checksum and make sure you get the checksum you expect, right? In the ideal world, you go off to a hand calculator and get the checksum that way and make sure that everything comes out to the checksum you've proved you expect, okay? Because in general, there's a risk that you might go wrong in any of those pieces of designing the whole thing. 3 minutes seems desperately long when I'm standing up here now. I tell you, back in the hotel room, it wasn't enough time to get up out of my chair, go to the fridge, take the top off the bottle of juice, pour it, and get back into my chair, but never mind. It's possible that at the last minute I hit undo and reset my number to how it, the number that makes it last 3 hours. Who knows? While we're waiting for that to finish, and it might never finish, I might have messed up one tiny detail. Do you have any questions at this point? I knew that would make it finish, right? Guaranteed to make it finish. Right then, let's go back to the slides, and I'll just highlight as much of what I've been talking about by example as I can manage in the time we've got. So then, all this is going to be a bit specific, but I did that at 0, right? That was what it does, what it takes to make it run. I forgot to do that ahead of things. So this is the kind of table that is good for my experiment. You can see it has to have a column with each of the relevant data types. Who knows what table you're going to need in general for your experiment, but mine, I called it T, and I named the columns in the way that told me what the data types were. Populate it. I'm not going to tell you how to populate a table, except that I hate that connect by prior black magic, so I use the table function that I wrote myself, which runs just as quick. Right. This point really is just don't forget your oracle when you do something like this. Do it properly. Have constraints, think about all the rules just in the normal way, because you would look so stupid, wouldn't you, if you presented the results of the experiment and someone proved that you'd just designed it wrong and you'd got some violation of some data rule that was self-evident because you hadn't thought it through and hadn't tried to enforce it. Okay then, next point. I've got a package that implements the experiment. And it's those three phases: create the functions and, of course, the table, do the timing test, and generate this. So the next point is really all this about what I said, and then the fact that in this kind of experiment, at least, you're going to have to be inventive in the moment. And here, the trick was to generate the functions by writing a PL/SQL program to do it, because otherwise I could never have typed up 55 different things and been sure they were really identical where they were meant to be and different only where they were. And I had to find a scheme to record all that in the table. Enough of that lot. Now then, what about just showing these functions? Just see if I can get this mouse to do that. Where they're gone. If I just paste that in. You don't have to read them that well, but all it is there are lots of functions. That's all I want you to understand. There are lots of functions there, 55 of them. They all look remarkably similar, except where they're different. There's a bit of conditional compilation going in there for the default value thing that we talked about. And I didn't type them all up by hand, right? That's the only point that you need to understand. Because if I'd typed them by hand, I'd have bound to have gone wrong. And the reason these other guys, like Woodlake, didn't do a big exploration is because they couldn't be bothered to type all those different things. And they couldn't be bothered to write the generation harness, so they stopped with a hint of a question. Right then, table for the results, blah, blah, constraints, blah, blah, just because you're doing it properly. Then the timing procedure, the loop over, get the time. You don't need to know the details. This is just meant to give you a flavor of what you sign up for. If you're going to make any pronouncement about performance that's worth opening a mouth for, you're signing up for some effort. Mean and variance, I've said that. Let's not rush that. So then, now, let's just say, well, we've got our results there, just so that we can read them easily. I'm going to go over to this experiment. I'm going to clear the screen. I'm going to push that in. And I'm going to go over here and do the next thing. This will generate the not so useful report because it's got the extraneous pure SQL in it. But you can see, right? Any one of you could do that, couldn't you? It might take you an afternoon. You might think, oh, must I? Can't I just have it all coming out in one big long ribbon? It's a pain setting up it as a matrix, starting with a long table, but you could all do it if someone said you ought to, and you could do it in an afternoon or less. And I just took every effort to make it as neat as possible. And then without rerunning the experiment, then I can say, really, whoops, sorry, wrong direction. What I'd prefer to see is the thing that ignores the pure SQL and just focuses on the bit of interest. Whoops, sorry. Oh, what did I do then? I missed the end. Well, why didn't you tell me before letting me do it? Right, so there we are. You've seen those numbers, they're on the slide. I pasted it. So we've reached the end, and the time is 14:48. So I'm 3 minutes behind the schedule. You're not allowed to stay in here and ask questions now. In fact, you should have been gone 3 minutes ago. But I'll be around, and please ask me questions when you see me outside. So thank you for your attention.